Hi, this is Tim Panagos, CTO for Microshare. I'm going to do a deep dive example here of how the Microshare product can be used in the automotive IoT environment, something we would call the connected car. Before we get into the demo, I want to look at the actors we're going to encounter in the demonstration here. We're going to start with that idea of a car as a complex sensored object. We see this across multiple industries, from automobiles to buildings to people. All of these things could be considered complex sensored objects. The primary owner in our demo set is going to be General Motors, and they're the person or entity responsible for aggregating the data coming from that complex sensored object, in this case, the automobile manufacturer. But GM also has a network of suppliers behind the scenes in their supply chain. We're going to include these in the demo as co-owners of the data, in this case, seat supplier Audit and engine control unit supplier Mitsubishi Electric. And we'll see also involving the consumer in this particular ecosystem, in this case the auto owner, the car driver. I'm going to use myself as the example of the car buyer, and then we're going to look one step further at the idea of enabled parties, which are entities or people that have access to consume the data without themselves having the right to dispose of that data. So they're not owners of the information. So we're going to see my auto insurer, Amica, and my service technician, Herb Chambers, who's going to be performing maintenance on the automobile. What we're going to see in the demo is really three key elements, components of the product: rules, robots, and views. And these three interchange and interoperate to really create the magic that is the Microshare product. To start the demo off, we're going to look at how the API underneath Microshare is used to inject data and then ultimately pull data back out. You can put data in and get data back out through RESTful APIs, which we will feature here in this demo, but you can also use things like WebSockets and file imports or MQTT to really be able to import data in essentially any format that you're likely to find it in. And then of course pull that data back out to build applications from it, to run analytics or machine learning pipelines, all the different reasons and ways that you might want to have that data available on the backside. So to start the demo, the first thing I'm going to do is actually post some data simulated into our empty system here. I'm going to use a tool called Postman, something that developers will be very familiar with. It's going to be run to actually execute some post calls against some sample data that'll import. So I'm just going to click this, and what you'll see probably in the background is some flickering on these screens. In this example, I'm running all of the microservices that are necessary as a minimal Microshare deployment here on my Macintosh, and you can kind of see that there's some activity going on. I won't drill into the logs, but just wanted to call your attention to them. So at this stage, I have imported 25 different sample sensor datum, and these are pretty simple. They're going to see that there's temperature, light levels, and noise included in the data, and a device ID. Nothing particularly remarkable about that data. But what I want to be able to show you then is not just that the data is stored in the system, but more importantly, as you import that data, you're going to reasonably expect that data to be stored and the data pulled back out. So as you look at the green blocks in the diagram here, that's really kind of a black box to Microshare. The data that you inject is the data you get back out, but the magic of the product is the decoration or attribution of this metadata to the fundamental data that allows us to make decisions about that information and enrich the experience of consumers of that information after the fact. So the first thing we'll show is owner metadata, and that is really the ability to see and ascribe these primary owner and co-owner relationships that can include things like what applications were used and what the location is associated with the introduction of that data, and what the authentication model was for the person who injected that data, including if they're using Active Directory for identities, things like their organizational memberships and their roles within that organization. And then down we'll see a little bit about descriptive metadata. We're doing things like digital fingerprinting, which ultimately is a technology taken from the blockchain area, which allows it to do cryptographic hashes of the information so that as the information goes through its life cycle, a consumer can always look back and have proof of the provenance of that data to know that the data that they're viewing now is the data that was originally stored. It hasn't been tampered with in any way. So that's an example of descriptive metadata. We also do tagging to make it more discoverable, to enhance search and things of that nature. So the first thing I'm going to do now that we got that first tranche of data imported via the post is to look at how we might interact with that data via API. So again, I'm going to go back to a Postman tool and actually run some API calls so you can see how the data might be interacted with. So I'm going to start with an authorization call as General Motors, and you can see it up here in this tab, and that's going to go ahead and authenticate me against the identity system and give me back an access token. That access token is now going to be used when I issue this GET call to retrieve information that I have rights to in the Microshare system. So as I said, I imported 25 records into an empty system. So what this is telling me is that there's a total count, a total possible number of records is 25, and the current count is 25. So I've gotten 25 out of a possible 25 records returned. And that's because, as we saw in the actor models, GM is the primary owner. So all of the data that came from all the sensors, from all the cars, is aggregated by GM. So they have access to them all. If I come now and click on authorization as Mitsubishi, what I'll see is that when they make the exact same API call, instead of getting all 25 records, they can only see 13. And that just happens to be the number of sensor information that happens to be ascribed to the engine control unit, or ECU. So Mitsubishi co-owns this particular piece of data, but they don't get to see the seat information that Adient would be able to see. They just get to see from their particular devices. So I'll also, just for completeness, authorize as myself the car owner and do the exact same call I've done for the other two. And I'll see that I too have a subset of information that's available to me. But what I'll see here is that it's both the seating and the ECU information, but it all is associated with my VIN number. And here it's simulated as 1, 2, 3, 4, 5, 6. That's my car. So I will see a bunch of different sensors reporting, but they'll all be associated with this particular VIN. And that's how the ownership has been attributed in the Microshare system for that piece of data. So how did that ownership attribution happen? What went on behind the scenes to let the system know that this VIN number belongs to Tim Panagos, this sensor was manufactured by Mitsubishi? We have this component called Microshare Stream, which is stream processing of all of the events of data arrival throughout the system. And one of the things that you anchor onto this stream are robots. So I mentioned that robots is one of the 3 real key components of the system. One of the things you do with robots is use them to apply business logic to attribute the co-ownership relationships. You can do a bunch of other things with robots. They're also good for applying business logic around thresholding or trends in the data to generate alerts. To do things like generate bills, to integrate with your machine learning pipeline, integrate web services. There's really no limit to what you can do with the robots, but the primary goal for this demo is to really show you how we use business logic to attribute that co-ownership relationships. So what I'm going to show you now are a couple of the robots that were built into the GM system that made those associations behind the scenes that allow those APIs to immediately function the way you saw them. So now I'm going to pop over for the first time to show you the Composer, which is the administrative cockpit of the Microshare product. I won't give you a complete view around this, but anything that you have access to that you can administer, we think of this as being centrally administrated with distributed execution. So you come into this console to manage your assets, and then those assets are distributed by the architecture to run wherever they need to, be that cloud, be that on-premise, or be that on edge, or some combination thereof. So you're going to see rules, views, and robots here in this demo. So you can see here in this window to the right, I am signed in as GM, and GM has exactly 2 robots configured. I'm going to show you what those look like. This one is responsible for assigning vendors as co-owners, and the way that all the robots work is generally they will subscribe to an event of a particular record type. The way to think about record type is it's a tag that we use that I think of as a Dewey Decimal System for describing the kind of data that is being trafficked throughout the system. So in this case, we're going to call it com.gm.auto.sensor, pretty generic. But that's going to alert us that when this piece of data arrives in the system, this robot is going to be interested in the alerts generated by that kind of data landing in the system. Now, robots run as if they were a unique human being. So they can have their own username, password, and they can have their own rights that they can perform. So one of the ways that we limit and control these is with permission scopes. So right away, I'm going to allow my robot to read, to query, and to write, but not to do other things that might be destructive of the data in the system. The heart of the robot is this business logic. And in our system, you write that business logic in JavaScript. Now, the robots are really an example of this serverless coding idea that you'll see in Amazon Lambdas, for instance, where you create a small snippet of software via a simple scripting language, in this case pure JavaScript, very commoditized skill set. And then we handle the notion of deploying this at the servers where it's necessary to execute this business logic. And again, it could be cloud, could be on edge, in a multiple different environments. So the contributor to the business logic just writes some simple code, usually less than 100 lines of JavaScript. I think you'll see that there are about 63 lines here of JavaScript. And that JavaScript has access to the objects and can apply different logic and do things like web service calls, etc. So what this one doing is really just applying a simple idea that if my device ID starts with B, then it belongs to Adient, and if it starts with A, it belongs to Mitsubishi. In a full example, we'd see that doing a web service call or looking up data to determine the parts list based on the sensor reading who was the actual manufacturer. And then all it's going to do is write a new record that has a new set of owners attributed to it with a simple API call down here. I won't belabor that, but I just wanted you to see what goes into that. Likewise, there's another robot who picks up and the data that was created by the first robot, in this case called com.gm.auto.center.decoded, and this one's job is to look up the consumer owner. So is the VIN number associated with this device already registered? Do we already have an owner? And if so, how do we ascribe that? So it might look it up in a bill of sale, it might look it up in a CRM system or something like that. And in this case, it's going to take a VIN number of 1, 2, 3, 4, 5, 6 and give it to me. But if it's 4, 5, 6, 7, 8, 9, it's going to give it to Jack. And that's all this robot really does in this particular case. Let me give you a peek at the data that's underneath here after the robots have done their processing. So this is just a view into my MongoDB, which I'm using to persist the information. Like I said, originally we've got 25 records coming in and we have 2 robots processing them. So if we did the right thing, we should have 75. So 25 times 3. Each record is preserving its own copy of the data. So when we originally put that data, actually I'm going to make a new query here to show us the 3 versions from the first row of imported data. So this was how the data looked when it first came in, and it's com.gm auto sensor. I'm going to open the owner metadata block here, and you can see that there's exactly one owner right now, which is systems@gm, and it's at the top level, making them the primary owner. Now, row number 2 here is created by the second robot and bears the decoded rect type. If we look at owner now, what we'll see is not only do we have the primary owner assigned, but there's also an array of owners here into which Mitsubishi has been entered. And then finally, as we look at the third, we're now looking at decoded.owned as a rect type. And the owners array, the co-owners array, now has 2 entries, 0 and 1, and the second one belongs to me, the car's owner. So that's what the data looks like underneath. While we're at it, let's take a look at some of the descriptive metadata we've recorded for each one of these objects. We've got some tags that we pulled out of the body of the data to make it easier to do some sorting and querying later on. The data is here, untouched, device ID, temperature, etc. And then here in origin, we've got some of that cryptographic hash information here denoted as checksum. That's the cryptographic hash of the data as it was originally injected. And you can see up here is another checksum. That's the cryptographic hash of the data as it's currently stored. And you can see between the two, those are the same hash. So that's probably the same piece of data, unadulterated in that piece of information. So that's a look at the data. as it's stored inside the system after the robots have done their processing. So once that ownership information is allocated to it, the rules engine is going to then apply whenever a new request comes in. It's going to comply with the owner's request for privacy, or in other words, how do they express the policies that guide the disposition of data or sharing of their data downstream. So we've got a custom-built rules engine in Microshare, and it takes the ownership context, so what is the nature of the multiple owner of a particular object, and then compares it with the request context. So who's asking for this information and what context of that request is coming in. And then can also do things like blend environmental context. For example, it could limit the response to something to a particular ring-fence geography, or maybe share data with someone only in the event of a weather emergency or some other externally verifiable event. So now that we've seen the data, I'm now going to look at the idea of assigning an enabled party, in this case Herb Chambers, my service tech, and I'm going to do that by creating a rule. So to start with, I'm going to come over back to Postman here, and I'm going to authorize Jack at Herb Chambers, who's my favorite service tech, and then do a request as Jack. And as it stands today, Jack has a potential to see 25 records out of this data, but actually sees none. So at the moment, he doesn't have any rights to the data to my car. So I'm going to come back to the composer here, and as myself, as Tim at Microshare.com, I'm going to go ahead and create a rule that allows my service tech to consume the data in question. So in this particular case, the record type is decoded.owned, as it was seen in the MongoDB. And here in the rule, I have the ability to set a bunch of things. Primary is what operations do I want this rule to apply to. So I can do, in this case, read and query. I only want them to be able to consume. Normally we think about these grants, these operations, as being limited to the CRUD functions around a piece of data: create, read, update, delete. But in actuality, the rules engine is very open to what types of operations you can define via the API. So one of the examples of that is to expand your notion about what data means to the idea of a digital avatar. So to the extent that we have an IoT device that's actually an actuator, let's think about maybe a smart lock on my house, I could use the rules engine to dictate who is allowed to execute against that digital avatar. In other words, who would I allow under what circumstances to unlock my front door, which would really be that execute command. And you can specify custom operations through the API to even make that more rich. So here is the description of me as the owner of that data, and I can limit it in a few different ways, but I'm going to focus on the requester context. And because this is a specific person that I'm looking to give access to, I'm just going to go ahead and put their email address in there. So Jack at herbchambers.com, I want to give them specifically access to my car data. So I hit create, and now I've got this service tech rule. And if I go back now and make that same call as Herb, what I'll see down here is now of 25 records, I have access to 13. And if I look in detail, I'll see that all of these are from VIN number 1, 2, 3, 4, 5, 6. So essentially, I've given Jack the ability to see all of the data that I myself can see as the car's owner. So complete visibility. Now, the other use case for this is to create less than complete visibility. So the way to do that is something we call a view in the system. And generally it's used for creating some derived piece of data or a new fact that the system can treat like a unique row in the database. So every view is either an aggregate of data that's in the system already, or perhaps just a redaction of data because we want to share a portion of the sensor data, but not all of the sensor data. So that's what I'm going to show in this particular example, is creating a view that has its own rec type, and we can assign unique rules to it. So in this demo, what I'm going to do is jump into the system and run an API call as a Mika, so somebody coming in as my car insurer, and show how I can set rules and a view that gives my car insurance company a selective view of the data. So for instance, they can see when I'm using my car, but not how fast I'm driving or how I might behave inside of that car, which I want to limit as a consumer. So first I'm going to come over here, get rid of Herb and go with Amica. I'll authorize as them to see, can they actually execute and see any data to start with? And at this point, they can't. You're seeing a fact not found. They have no visibility to the particular rec type representing my data. So again, I'm going to come back into Composer. And the place I'm going to start is by creating a view. Actually, I'm going to kind of skip ahead by having already created a view. That is a way of taking the data that is underlying decoded.owned, the same data that I shared in complete detail with the service tech, and I'm going to write a very specific view to limit the number of records I'll return, to sort it, and then ultimately, most importantly, to do a projection, which takes all the data that's there and actually just limits it to the timestamp. So what this should do is give me all the data that I've got about my car, but only show you when the car is in operation or what the timestamps of operation. So if I test it here as myself, logged in as T. Panagos at Microshare, you can see the data coming in from the system executing this view, and right there is that data portion, just has time, and it's just this system date, this number long piece of information. So what I want to do is take this view and treat it like it's a new piece of information, like it's a raw piece of information. So I'm going to create a new rec type for it, ComGM auto sensor obscured. Then what I'm going to do, because I want this piece of data now, this derived piece of data, to be accessible by Amica, so I'm going to create a new rule that would limit just that view to people who are part of Amica's underwriting department. So the record type is that obscured record type. And instead of access to the stored objects, I'm going to give access to derived objects, so the derived data from underneath this. And I'm going to give them read and query data as before. And this time, instead of picking a particular user, I don't know the underwriting person in charge of my account at Amica. So what I'm going to do is make a rule that's more generic and says that as long as you are part of Amica, and furthermore, that when you sign into Active Directory, you are part of the group amica.underwriting. And we'll take a step further and say, maybe you specifically have to have the role of underwriter in order to get access to this data. So I'm going to create this rule now as the consumer. And once again, now I'm going to scroll back to Postman and redo this call, the same call as Amica. Now clicking the get call will return that same data that I showed you, which is really limiting not the sensor data, but just the timing, just so that they can see what times was the sensor reporting activity, so that they can see when the car is actually running. And no other data is included in that. So you'll see that there's 13 tweets from the car returned in this derived way. So that underlying data is not available to Amica, just the view that I provided for them. So the next thing I want to do, where I want to leave off on this, is underneath the whole process that's been going on here of attributing ownership and assigning co-owners. What's been happening beneath the covers is that we've been generating this complete audit trail of all of the activity as the rules engine has been firing that makes decisions about whether to show one piece of data to one particular person in what particular context. And what you'll see here is that all of these events are being streamed into our high-speed log, where you'll find that there are policies about which rules match, and then what those particular rules say about whether a particular request should be allowed or denied, and then most importantly, in what case and in what context was that decision made, so that you can look at this particular algebra and make decisions in retrospect and hindsight about exactly why did we share this piece of data or did we not. So all of this information is coming out, a tremendous volume of information coming out, so that you can use machine learning to do fraud detection, you can build building systems, you can apply heuristics to this information, and it really gives us a rich means of determining how we're in compliance, or what rules we're being in compliance, or where should we tighten up our data sharing policies in the background. So that brings us to the end of the demo. I hope you enjoyed it. Look for more videos, more examples, and different domains. Thank you very much.